Hi everyone, my name is Nidusha and I'm a senior computer science and engineering major. My senior design and honors thesis is EMT, which is a software-based energy management tool for Wi-Fi IoT devices. Our advisor is Dr. Bhenam Disfoli. Before we begin, let's talk about our motivation and the pressing need for EMT. In 2016, St. Jude Medical recalled thousands of heart monitoring devices after two patients died when their device's batteries suddenly failed within just 24 hours of being implanted, when they should have actually lasted them for at least 6 months. These heart monitoring devices were implantable cardioverter defibrillators or ICDs. They're a type of Internet of Things or IoT device used to send electric shocks to a human heart to restore the normal heartbeat. This disaster was shocking and incredibly disheartening and serves as an eye-opening case to the life-threatening consequences of unexpected battery depletion in battery-operated devices. There remains a need for the solution to this problem so that a case like this can be avoided in the future. Why is there a pressing need for energy efficiency in IoT devices? As technologies advance and wireless networks become more widespread, wireless devices are becoming the norm. Today, there are over 14 billion IoT devices in use. 10% of these IoT devices use rechargeable batteries. A battery is a primary energy source for many different types of IoT devices, such as wearable sensors and devices, surveillance cameras, medical devices, and IoT devices requiring mobility like patient monitoring systems. However, this comes with certain issues and concerns. Premature and unexpected battery depletion, limited battery life, and devices using energy inefficiently can have serious or even life-threatening consequences like the St. Jude medical disaster. Current solutions for energy efficiency in battery-operated devices are expensive, require external hardware tools, and are not scalable to many devices. So this brings us to the question, how can we collect and monitor the energy consumption of IoT devices in a scalable, low-cost, and software-based manner? Well, EMT. So what is EMT? EMT stands for Energy Management Tool. It is a novel, low-cost, scalable, and software-based solution for monitoring the energy consumption of IoT devices. EMT's goal is to be a user-centric platform where a user can easily track the energy consumption of their IoT devices. With this in mind, these are the main functionalities of EMT. Firstly, EMT monitors and logs the data transfer information between IoT devices and a wireless access point. EMT then analyzes these logs it collected for the various connected devices and extracts insights. Finally, EMT presents the energy insights in an intuitive and interactive web-based interface to better inform the user and help them interpret their power consumption information. Now, how does EMT work? Its functionality is split between its backend and front end. For the backend, a user will download all the packages needed for EMT onto their access point. The backend makes use of technology such as host APD, eBPF, and the power management bit. This will facilitate the collection of energy consumption data from all devices the user is connected to the access point. For the front end, the user can see their energy consumption insights on the front end interface of EMT. The front end is a web interface built in HTML, CSS, and JavaScript. The dashboard interface displays the insights that help inform a user about the status of their connected IoT devices, which we will see more in depth in our demo. Now let's dive into the testbed setup and demo to get a better understanding of how EMT works in a simulated environment. In our testbed setup, we will have an access point with EMT installed. The access point has a wired Ethernet connection to a network switch, which is connected to the internet. IoT devices such as an iPhone, a Ring camera, and a Raspberry Pi are wirelessly connected to the access point. For the sake of the demo, we will simulate a test with just one iPhone 13 Pro wirelessly connected to the access point. Now let's look at our demo, which we will walk you through how EMT works. This is our test bed setup, which includes an access point with a wired Ethernet connection to a network switch, and our IoT device is ready to be wirelessly connected to the access point. When a user installs EMT onto their access point, all they need to do is connect their IoT devices to the Wi-Fi network. Let's look at the behind the scenes for the EMT's backend. This is the host APD and the EMT scripts, which will track our users' key insights about their device's energy consumption. We're going to run both the scripts. Once we connect a device to the access point, we use the device for a short period of time. We test out a bandwidth intensive activity by streaming a video on YouTube, then turn the device off for about 15 seconds. We then turn the device back on to check the news on the browser. Finally, we disconnect the device from the access point by turning off the Wi-Fi. EMT's backend has generated palatable data insights for the user to interpret the energy consumption. These insights and statistics were populated on EMT's front-end dashboard. Let's look at EMT's front end. The front end has the login information, some information about EMT and why it's important. Once a user logs in, they're taken into their personalized dashboard. This is where EMT processed the logs collected while the device was connected to the access point to retrieve the timestamps and other important information about the device's data transfer. We analyze these timestamps and collect three main insights about the device's data transmission. A user can easily zoom in and zoom out of this interactive web interface and understand their device's energy consumption. Now, to better understand the insights that EMT offers, let's perform an empirical analysis and evaluation of our demo results. As we saw on the front end in the demo, the three main insights that EMT collects are the percent of wake time, duty cycle, and the number of packets. Let's dive into the duty cycle to understand how a user can analyze the energy consumption of their IoT devices. The duty cycle per second graph shows a detailed breakdown of how the device switches between asleep and awake modes every second. It helps the user understand how much energy was consumed. The graph helps the user identify the random irregularities that could occur while the device is connected to the access point. The graph here is the duty cycle that was recorded from the demo. From seconds 10 to 30, we were playing the YouTube video, and the duty cycle shows that the device was awake during this period. From seconds 30 to around 45, the device was turned off, but the duty cycle is not completely at zero. For the duty cycle to be at zero, it would mean that the device enters sleep mode for 15 seconds and does not receive or transmit any data at all. But as the demo showed, the phone was still receiving notifications and performing functions in the background, which is why the duty cycle is lower than it is while the phone is actively being used. At 45 seconds, the phone was turned on again to open the New York Times. This is where the duty cycle shoots up again as the user is actively using their device for browsing. If any irregularities were to occur, such as interference from other devices on the same network, this would also be reflected in the graph. The work of EMT does not stop here. As a future development, EMT will offer real-time catered recommendations to the user based on their unique network configuration. EMT will leverage machine learning technology to implement predictive battery depletion, alert users about excessive battery consumption before disasters happen, and recommend sustainable practices based on a user's unique network configuration. These are our references. Thank you so much for listening to my presentation.